Good morning, class. Today, we are going to cover section 4.7 and 4.8. Okay? Today we're doing section 4.7 and 4.8. All right. So here's section 4.7. Look, 4.7 consists of equations and inequalities. Okay? More specifically, they are discussing rational equations. So let me give you an example of a rational equation. Okay? Here is a rational equation. Section 4.7. An example of a rational equation is the following. Example: 6 over x squared plus 5 over x equals 1. This is a rational equation. The word rational means fractions. So it's an equation with fractions. Note the variables in the denominator. Okay, so the first thing we're going to do is we're going to rewrite this and we're going to multiply everything by the LCD. Okay, so let's rewrite it. 6 over x squared plus 5 over x equals 1. And now I'm going to multiply everything by the LCD. Let me get my color pen. And we know that the LCD for this problem, the LCD is x squared. So I'm going to multiply every numerator by x squared. So multiply this by x squared. Multiply this numerator by x squared. And multiply, that's the numerator. Multiply this by x squared. Okay? And now we're going to simplify this. The x squares cancel. Notice the x squared cancels. And so we get 6 plus an x from the denominator cancels an x in the numerator. And we get 5x. And 1 times x squared is x squared. Okay. Now this is a quadratic equation. That's a quadratic equation. So we have to set it equal to 0 to solve this quadratic equation. So therefore, set it equal to 0. So what I'll do is I'll just bring this 6 to the right and 5x to the right. Subtract 6 and subtract 5x from both sides. So 0 equals 2. X squared. Bring this to the right. Minus 5x. Bring this to the right. Minus 6. And there it is. That's your quadratic equation. To solve, we have to factor. So 0 equals 2. X squared minus 5x minus 6 equals 0. And I'm going to factor this. Okay, it's the same thing as that. So 0 equals 2, factor. X times x, 2 times, I should say 1 times 6 instead. Okay? One times 6 We need one positive, one negative. Let's make this negative and let's make this positive. Okay? So x times x is x squared. 1 times negative 6 is negative 6. And then we have 1x minus 6x is negative 5x. And now we say x plus 1 equals 0 or x minus 6 equals 0. So x equals negative 1 or x equals 6. And we have solved this rational equation. Okay? This is section 4.7. Let's do another one. So the key is to get rid of fractions by multiplying every numerator by the LCD. That's the key. Okay, so let's do one more. Here's another one. Let us try this one. Let's try this. 1 over x plus 2 equals to 4 over 4 minus x squared minus 1. Okay? So here it is again, another rational equation. We're going to solve this rational equation. We have to find the LCD. Okay? Before we get the LCD, we better fix this one. Okay? I think we should be able to fix this denominator, either that denominator or this one. I'm going to work on this one, okay? So what I'm going to do is, note here I have x first plus 2, but here I have the constant first minus x squared. So what I'm going to do is, to fix this denominator, is I'm going to multiply top and bottom by negative, okay? Once again, before solving, let us fix the denominator, because this difference of squares has x plus 2 in it. Okay? So let's fix it first. What I'm going to do is I'm going to multiply top and I'm going to multiply the bottom by a negative. Okay? And I'm going to do that because I want the x to be first and then the constant to be second. Just like this is x is first and the constant is second, that's what I'm going to do here. Okay? So multiply top and bottom by negative. So this is 1 over x plus 2. Multiply the top by a negative, negative 4. And multiply this by a negative, that's minus 4. And multiply this negative x squared by a negative, x squared minus 1. Note, I multiply the top and the bottom of this fraction by a negative. Okay? And look at this denominator and look at this denominator now. Okay, that looks better. And now I'm going to find the LCD. But before I find the LCD, I better factor the denominators, okay? So let me rewrite it. So 1 over x plus 2 equals to negative 4. And this is x plus 2 times x minus 2 minus 1. You see this x plus 2? It's there. Okay? That's why I fixed this. Because I knew that it had x plus 2, right? And so therefore, what I did is I multiplied top and bottom by negative. Okay? And look at this. Now I got a better, I should say it's easier now. I'm gonna find the LCD. What's the LCD? I see an x plus 2, so I'm gonna take x plus 2. LCD. X plus 2. I see an x minus 2 also, look. X minus 2. X minus 2. And that's your LCD. Okay? And now, I'm going to multiply every numerator by the LCD. And that's going to fix my problem. So let me multiply this 1 times LCD, x plus 2, x minus 2. How about this one? X plus 2, x minus 2. How about that one? X plus 2, x minus 2. There you go. Okay? I multiply every numerator by the LCD. Every numerator. But first I fix the denominators. Had this been x squared minus 4 from the very beginning, I would have never multiplied top and bottom of this by negative, okay? All right. Watch what happens. Now, I'm going to simplify this fraction, and that. Well, that one is, this one is okay, but I'm going to simplify this one and that one, okay? X plus 2 cancels, look. And what do we get? We get x minus 2 equals 2. The x plus 2 cancels and the x minus 2 cancels, and what do we get? Minus 4. Minus. No, I'm going to multiply those two because this equation I'm going to have to solve. And to solve it, I have to combine like terms. So I have to make terms out of this. When you multiply x plus 2 times x minus 2, you get the difference of squares. So therefore, it's minus, and then x times x is x squared. Outer and inner cancels there, okay? And then 2 times negative 2 is negative 4. There you go. Note, the reason I had to multiply those two is because I need to combine like terms, and then I have to set it equal to 0. Okay, so here we go. We're simplifying this equation. Look, we started with this equation, look. We started with this equation, and look how easy and how simple it became by multiplying every numerator by the LCD. Okay. Now distribute the negative. So this is x minus 2 equals to negative 4. Distribute. Negative x squared. Distribute. Plus 4. Okay. Now, set equal to 0 and combine like terms. This negative 4 cancels this positive 4. Okay? So we get this, look. We get x minus 2 equals negative 4. Actually, negative x squared. That's it. This negative 4 cancels this 4. So we get negative x squared. I'm going to bring this negative x squared to my left. Bring it to the left, and we get x squared plus the x minus 2 equals to 0. Okay. I'm going to factor this. Factor equals to 0. X times x, 1 times 2. I'm going to say minus or plus 2 and minus 1. And we're going to check. Okay. So x times x is x squared. Negative 1 times 2 is negative 2. Outer is 2x. Inner is negative x. 2x minus x is x. Okay, there you go. I need the room, okay, guys? I need the room. Okay? And so now we're going to solve. And so therefore, set this x minus 1 equals 0. Or x plus 2 equals 0. X equals 1 or x equals negative 2. And we have solved this rational equation, look. Okay? So once again, what was the key? The key was, first, guys, by the way, we're not done. First, the key was to fix the denominators, okay? Once you fix the denominator, find the LCD and multiply everything by the LCD, every numerator by the LCD. And I did it here. I erased part of it, okay? Once I did that, it became a simple problem. And then I just solve. And once you get here, guys, once you get here, you have to check your answers, okay? Because sometimes this answers are extraneous. So you have to check your answers, okay? We didn't check our answers in the last problem, but we should have. Okay? So let's check our answers. You can check it here or there or there. Okay? Checking our answers. At least make sure that your answers do not make the denominator 0. Okay, so let's check. Check. X equals 1, the first one, look. Plug it in there. 1 over 3 equals 2. This is 1. What's 1 squared? 1 squared is 1. So 1 over 4 minus 1, which is what? 4 over, what's 4 minus 1? 3. Minus, you see this 1? That's 3 over 3. Okay? So what is 4 over 3 minus 3 over 3? Isn't that 1 over 3? So 1 over 3 equals 2. 1. 4 minus 3 is 1/3. Yes, it checks. That's an answer to this. Okay. Check the other one. Check x equals negative 2. We're checking, guys. Okay. Check x equals negative 2. 1 over negative 2 plus 2. Hey, 1 over 0 equals 2. Guys, this answer is basura. Okay? The word basura means trash. This answer is trash to the original problem. Why? Because when you plug in this answer in the original problem, you get 0 in the denominator. And whenever you get a 0 in the denominator, it doesn't exist. So therefore, I call it basura. Okay, so this answer that we got is basura to the original problem. Basura means trash. But in mathematics, we say this answer is extraneous. This is extraneous. Solution. What that really means is it's not the solution, it's not a solution to the original problem. It isn't. So what's the solution to this? Solution to this problem. Solution is only 1. Okay. Solution to this problem is only 1. Okay. All right. Okay. I need the room, guys. Sorry. Let's do an inequality, a rational inequality. Okay, guys? Rational inequality. So now we're going to do a rational inequality. We're still in section 4.7. Okay? All right, so what's a rational inequality? Okay, well, we have to make a rational expression and with an inequality. So what is that? 1 over x is greater than 2. This is a rational inequality. Okay? Guys, for rational inequalities, to solve rational inequalities, okay, the first thing we need to do to solve rational inequalities is to set one side equal to 0. Okay? Set one side equal to 0. So I better write a warning. For rational inequalities, 1, do not multiply by LCD. Okay? Do not multiply by LCD. Okay? Instead of multiplying both by the LCD, instead make 0 on one side. Set one side equal to 0. There you go. Okay. So that's what we're going to do there. We're not going to multiply by the LCD. No. What happens is when you multiply by the LCD, sometimes you create extraneous solutions. Okay, and it becomes more complicated when you have a rational inequality. So we're gonna stay away from this problem. Once again, do not multiply both sides by the LCD. Okay, that's what we did earlier when we had rational equations. That's what we did, but not here. This is a rational inequality. We do not multiply by the LCD, by the least common denominator. Instead, it says there, set one side equal to 0. So that's what I'll do. Hang it over. 1 over x minus 2 is greater than 0. Okay. All right. And now combine the non-zero side. Okay. Combine the non-zero side. That is, put them together. So if I'm gonna subtract 2 from this, if I want this together, I'm gonna multiply top and bottom of these two, top and bottom, by x. So 1 over x minus, multiply the top by x and the bottom by x. And there you go, look. And now I can combine. So 1 minus 2x over x is greater than 0. Note, class, I never multiply both sides by the LCD. That's what I did when we had rational equations, but not here. Stay away from that. Do not multiply both sides by the OCD. Instead, set one side equal to 0, and that's what I did. I brought this over and this became 0, okay? And now I combine this side, and that's what I did. Now, what we're gonna do now is we're gonna find out what makes the numerator 0 and what makes the denominator 0, okay? So, what makes the numerator 0? Numerator. Set the numerator equal to 0. 1 minus 2x equals 0. And the denominator, set the denominator x equal to 0. Okay? In the numerator, solve this. We want to know what x value makes the numerator equal to 0. Okay? So the numerator, solve this. So therefore we have negative 2x equals to negative 1. X equals to half. What makes denominator 0? X equals to 0. Okay? So note what makes the numerator 0 and what makes the denominator 0. For the numerator, x equals half makes the numerator 0. In the denominator, x equals 0 makes the denominator 0. Now, I'm going to take, I call these values, I call them boundary values. These are boundary values. I'm going to take these boundary values and I'm going to graph them on the number line. So here is 0. I'm going to circle 0. And here is a half. I'm going to circle a half. Okay? And look, these boundary values gave me this region from 0 to the left. Okay? From 0 to half. And from half to the right. 3 regions. So I got from this rational inequality, note when I set one side equal to 0, I combine, I got a boundary value from the top and a boundary value from the bottom. And from the bottom I got 0, and from the top I got half. Those two boundary values divide the number line into 3 regions. And what I'm going to do is I'm going to check each region. If a region, if I pick a value from this region and it makes this one, you could try this one. Pick a value from each region, plug it into this inequality. If you get a true statement, that means this region is a solution to the original problem, okay? If you get a false statement, that means this region is not a solution to the original problem, okay? All right, you have to make sure also that you write these 2 boundary values correctly, okay? Half is to the right of 0, and that's the way it has to go. If you put it to the left, you're gonna make a big mistake when you try to check each region. All right. What value can I pick from this region? What value? Try negative 1. X equals negative 1. Plug it in there. What's negative 2 times negative 1? Negative 2 times negative 1, because x is negative 1, look, this region. Negative 2 times negative 1 is 2. And 2 plus 1 is 3. and plug in -1 there. Is that a true statement? 3 divided by -1 is -3. Is -3 greater than 0? The answer is no. So therefore, this region is not a solution because you got a false statement. This is false. So you don't shade this because it's not a solution. Okay. How about this one right here? Let's go to this region. What should I try? Try nice numbers also, by the way. Nice numbers, okay? What's between 0 and half? That's a nice number. 1/4. Okay? Plug it in there. What's -2 times 1/4? So here we have, anybody knows what -2 times 1/4 is? -2 times 1/4 is -2 over 4, which equals to -1/2. Right there. So -2 times 1/4 is -1/2. So this is 1 minus half. And what's 1 minus half? Half. Divided by 1/4. Listen, guys, and this says greater than 0. Is that true or false? It's true, because that's a positive half divided by a positive 1/4. What's a positive divided by a positive? Positive. Is a positive number greater than 0? Yes, it is. You don't even have to evaluate this. No. It's a positive divided by a positive, greater than 0. So this is true. So you shade. You shade this region. You shade because this region is a solution to the original problem. You shade. Try the last one. What should I try? Should I try 1? Try 1. X equals 1. What's -2 times 1? -2. What's 1 minus 2? -1. -1 over 1. Is that greater than 0? No! That's false. Why? Because it's a negative divided by a positive. What's a negative divided by a positive? That's negative, and a negative is not greater than 0, so that's false. This is false. So you don't shade. And now, because there is no equal sign here, the bound values stay open. Okay? They stay open. So what is the solution to this inequality? What's the solution? The shaded region. Okay? Solution to this inequality. The solution to this inequality is going to be from 0 all the way up to 1/2, excluding. This is the solution right there to this inequality. Okay. All right. Something important. Do not multiply by the LCD. Okay? Don't do that. Okay? Let's do another one like this. Okay? Here is another one like this one. Here's a good one. Try this one, look. Okay? So we got this one, that's the solution, okay? Gotta go. Gotta go, gotta go, gotta go. Okay, here we go. Here's a good one. Look, guys. 1 over x is less than or equal to 2 over x plus 1. Guys, what does this say? Do not multiply by the LCD. Don't do that. Not here. Don't do it. Because you're going to make a mess. So instead, set one side equal to 0. Okay, we can do that. So I'm not going to multiply by the LCD. Instead, I'm going to subtract 2 over, I can do it either way, okay? Let me bring this over, okay? I could also bring that over. Maybe I should do that. It doesn't matter. Bring this over. So therefore, this is 1 over x minus 2 over x plus 1 is less than or equal to 0. Look what I did. Instead, set one side equal to 0, and that's what I did. I think this only has one L. There you go. And now I'm going to combine those two. How do we combine those two? Okay, well, to combine those two, I better multiply this by x plus 1 and this by x plus 1. And I better multiply this by x and that by x, okay? Let me rewrite it, because I don't want to lose this. Make a mess. So 1 over x minus 2 over x plus 1 is less than or equal to 0, okay? And so, to combine those two, I'm going to multiply this top and bottom by x plus 1, x plus 1. And I'm going to multiply this top and bottom by x, x. Okay? Note, I did not multiply both sides by the LCD. No, I didn't. What I did was, if I'm going to add those two, I better multiply this numerator by x plus 1 and this denominator by x plus 1. And I better multiply this numerator by x and this by x. Okay, that's allowed. You can take a fraction and multiply top and bottom by the same thing, and you get an equivalent fraction. That's what I did. Now they have the same denominator. I can combine the numerators. Watch this. 1 times x plus 1 is x plus 1. Okay? Minus 2x. You see this? Let me write that down. Okay? This is x plus 1 minus 2x all over x times x plus 1 less than or equal to 0. Okay? Finish the numerator. Okay? What's x minus 2x? Negative x plus 1 over x times x plus 1 less than or equal to 0. There you go. Okay, very good. Now my question is, what makes the numerator 0 and what makes the denominator 0 to find the boundary values? So now let's get the boundary values. Boundary. From the numerator, set the numerator equal to 0. Yes. So negative x plus 1 equal to 0. Plus 1. Better say plus 1. Equals to 0 from the denominator. X times x plus 1 equals to 0. Those are the boundary values. I'm trying to find the boundary values. Solve this. x equals to 1. And solve this. X equals to 0 or x equals to -1. These are the boundary values. The boundary values. We got 3 boundary values. 1 came from the numerator and 2 came from the denominator. Look. Now let's go to the number line. Going to the number line. So here's the number line. So we have, first of all, we have -1. That goes first. Circle. And then we have 0. That goes second. Circle. And then we have 1. Circle. So 3 boundary values gives us how many regions? 4. 1, 2, 3, 4. And we have to check each region. Okay? If we get, when we check and we get a true statement, that region is a solution to this inequality. Okay? I'm gonna use this one, this inequality, which is equivalent to the original one, to check each region. What value should I pick from the leftmost region? -2. Try x equals -2. X equals -2. Okay. Plug it in there. What's a -2? That's 2. So that's 2 plus 1 divided by, this is -2, -2, and this is -2 plus 1, that's -1. The question is that greater than, actually less than, look, it says less than. Less than or equal to 0. Okay, let's check again. Plug in -2 there. Negative times negative is positive. Okay, so in the numerator we got a positive. You see it? In the denominator, what's negative times negative? A negative times a negative is positive. So in the numerator we have a positive. In the denominator we have a positive. Is a positive divided by a positive less than or equal to 0? The answer is no. A positive divided by a positive is greater than 0, so this is false. So this region is not a solution to this problem. No. What should I try there? Want to try half? Sure, let's try half. Try half. Here, -half. Try x equals -half. Okay, watch this. -half. What's -half? Isn't that positive half? So positive half plus 1, that's 1.5. That's positive. The numerator is positive. Okay, I'll write it down, okay? -half right there, negative times a negative is positive. That's half plus 1, that's 1.5. So this is 3 halves. Okay, the bottom. Watch this. Bottom. That's negative. -half. What's -half? Plus 1. That's half. What's in the denominator, we have a negative times a positive. In the numerator, we have a positive. In the denominator, what's a negative times a positive? Negative. So in the numerator, we have a positive. In the denominator, we have a negative. What's a positive divided by a negative? Negative. Is a negative less than or equal to 0? Yes. So we shade. What about here? What do you want to try? Try half? That's negative half. Plus 1 as positive. But I'll write it down. So this is true. When you plug in negative half, when you plug in half there, negative half plus 1 is positive half. Divided by. This is positive and that's positive. A positive half times 1.5. Positive. So, can I just say positive? Is that less than or equal to 0? The numerator is positive, the denominator is positive. Is a positive divided by a positive less than or equal to 0? The answer is no. So you don't shade. You don't shade this. Try this one. Try x equals 2. Negative 2 plus 1. That's negative 1. That's negative. Basically, all you need to do is know the sign. So, by the way, this is false. Okay. So let's try 2. Negative 2 plus 1. That's negative 1. That's negative 1. All you need is a sign, guys. Okay. Plug in 2 there. What's 2? And plug into there. 2 times 3. 2 times 3, 6. Positive. All you need is the positive, guys. So the numerator, watch this. The numerator is negative and the denominator is positive. That's all you need. The numerator is negative and the denominator is positive. Is that less than or equal to 0? True or false? True. So far we have this is true and now that's true, and so we shade this. Okay. Now let's check the boundary values. Okay. Listen, guys. For the boundary values, just make sure that the boundary value does not make the denominator 0. So the question is this negative 1 shaded? Is it shaded? Is negative 1 shaded? Well, if you take that negative 1, what's negative 1 plus 1? 0 in the denominator. So therefore, remember, you cannot divide by 0. Whenever you divide by 0, that fraction does not exist. So when you plug in negative 1 there, that's a 0 in the denominator, so it makes this not exist. So therefore, this negative 1 cannot be included. Even if it has equality, this negative 1 is open. How about 0? Is 0 included? Well, that makes 0 here. What is 0 times 1? 0. So therefore, 0 is also not shaded because it makes the denominator 0. Okay. How about 1? Is 1 shaded? Let me see. 1 times 2. Is that okay? Yes, it is. So 1 is shaded. Because it's equal, you can shade it. All right. So what is the solution to this problem? What is the solution? Solution from negative 1 all the way up to 0, excluding or from 1 all the way up to infinity, including, look, and excluding. And this is the solution. Okay, solution, right there. And I got it from there, okay? Okay, I'm gonna give you one more problem from section 4.7, one more problem, okay? But this problem is gonna be a polynomial inequality, okay? Gotta erase this, guys, gotta erase this, sorry. Okay, here is a polynomial inequality, like a quadratic. Watch this one. Here's a good one. Okay. So this is like a polynomial inequality. Yes. We're still in section 4.7. Okay. And here's a good example. Right here. Try this one. X cubed is greater than 2x squared. That's a polynomial inequality. You're going to set one side equal to 0. So bring it over. So x cubed minus 2x squared greater than 0. Look at that. Okay. You're going to factor the non-zero side. So x squared times x minus 2 greater than 0. Okay? You're going to find the boundary values. The boundary values are all those values that make this left-hand side equal to 0. Okay? So you're going to set each factor equal to 0. So the boundary values, boundary. Set the first factor equal to 0. And set the second factor equal to 0. Those are the boundary values. Okay. Solve this one. And solve this one. And we found the boundary values. Okay. Zero here and 2 there. Circle 0 and circle 2. And so now, check each region. Check the first region. What should I plug in? Try x equals to -1. Plug it in. Plug it in there. What's -1 squared? 1. Times. What's -1 minus 2? -3. Is that greater than 0? True or false? False. So you don't shade. You don't shade because you got a false statement. By the way, all you need is a sign, guys. -1 squared. -1 squared. -1 squared is 1. That's positive. A negative minus 2. That's -3. That's negative. A positive times a negative is negative, and a negative is not greater than 0, so that's false. What should I try here? Try x equals to 1. Try that region. 1 squared is 1. Positive. That's a positive. 1 minus 2. 1 minus 2 is negative times a negative. True or false? False. A positive times a negative is not greater than 0. So that's false. Okay, 1 squared is 1, positive, and then 1 minus 2, negative. 1 minus 2 is negative 1. Okay. What about here? X equals to 3. 3 squared is 9, positive. Times. No, it's multiplication, okay? A positive times, what's 3 minus 2? Is that positive? Is that greater than 0? True or false? True. So this is shaded. And now, is 2 included? Yes or no? No. Because it does not have equal sign. So what's the solution to this inequality? What's the solution? From 2 all the way up to infinity, excluding. That's the solution, okay? All right, it's section 4.7. I'm gonna go in a few seconds into section 4.8, okay? I'm gonna stop this now.